This is problem number 7 on the practice problems for test number 2. Simplify the following, leaving no negative exponents. Part A, 2x to the 0. And just taking a quick look at part B, sounds the same when you read it, 2x to the 0, but they're different. So we got to be really clear on the difference between A and B. So first, what comes first here? We've got a multiplication and we also have an exponent. And we know order of operations says do the exponent first. So what that means is that the 2 and the times are waiting here for you to figure out what to do with the x to the 0. Well, any number to the 0 is always equal to the same thing. What is it equal to? It's equal to 1. Any number to the 0 is 1. So 2 times 1 is 2, and we're done with that one. In part B, 2x to the 0, well, what do you do first here? There's a multiplication and there's a power, but there's also this grouping parentheses happening here. And we know that the parentheses comes before anything else. So really what this means is that the power here applies to the entire thing. And anytime you have something raised to the 0 power, it's always equal to the same number. It's equal to 1. So the easy way to do this is just say, oh, this is one single thing raised to the 0 power. It's 1. If you really want to put some details there, I suppose you can think of bringing this 0 in and, in a sense, distributing it to the two things in the parentheses. 2 to the 0 times x to the 0. And then 2 to the 0 is 1, and x to the 0 is 1. 1 times 1 is 1. I don't think that's a great way to do it. I think it's better to really understand anything to the 0 is 1. And so right away, this thing is 1. Part C, x squared times x to the negative 2. This is another property that hopefully will ring a bell. In this case, what do we do with those powers? Keep the base exactly the same, and you add those powers. So we have a 2 plus negative 2. 2 plus negative 2 is 0. So x to the 0 is our answer. But as we've just seen, anything to the 0 is 1. So 1 is the answer. You're also welcome to come up here and decide that you're going to write that as an x squared, and then x to the negative 2, that really means 1 over x to the positive 2. And then what can you do here? Well, x squared on the top and x squared on the bottom cancel, and so we still get the same 1. I don't think, generally I'm not a fan of just moving exponents to become positive as the first step necessarily. In this case, I think it's more natural, for me at least, to just add those powers and see what I get. Part D, x squared times x to the half. It's the same problem as part C, same property as part C, I should say. Keep the base and add those powers. So x to the 2 plus 1/2. So this is x to the 2.5. I'll write that as 5/2. You can also write it as a decimal if you wish. Part E, x squared raised to the 1/2. Similar looking to part D, but a completely different property. What do we do with the exponents in this case? We multiply them. So this is really x squared times, or I should say x to the 2 times 1/2. Keep the base and multiply those powers. 2 times 1/2 is 1. X to the 1 is just x. Part F, 9 to the 3/2. So this one is just a number. We're looking for just a number when all is said and done, without any exponents in the final answer. So what does that 3/2 mean? Well, hopefully it's starting to remind you of radicals. You see a power, you think radicals. So where does the 3 go? Where does the 2 go? So I paused the video there so that I could go back and find the phrases that we were using to try to help us remember where to put the different parts of that fractional power. So the cubed, or sorry, the 3 and the 2, one of them is the index, one of them is the power. So I went ahead and grabbed the phrase down below that tells us what to do when dealing with a fraction power. It says the index goes below deck. I guess we're kind of going the other direction here. Whatever number is below apparently is the index. So of the 3 and the 2, which number is below? Well, it's the 2. So the 2 becomes the index, and we know the index goes right there in the front. And then the other part, well, the process of elimination tells me where the 3 goes, but let's look at our sentence down here. It says the power grows up like a flower. So whatever number is up must become the power. So the number that's up is the 3. For us, it's going to become the power. Now, personally, I never put the 3 in there. I think it's much, much easier to do the calculation with the power on the outside. So that's where I'm going to put it. Turns out you'll get the same answer, but I'm going to write it there. I'll put parentheses to really highlight what I'm doing first, which is the thing inside. So we've done our rewriting using our silly little mnemonic device here. And so we'll do the inside first. The square root of 9 is 3. It's still inside, and it's getting cubed on the outside. And 3 cubed is 27, which is our final answer. Part G, 8 to the 5/3, same idea, but let's see if we can do it a little bit quicker here. I've got an 8, I've got a square root, I've got some parentheses, and we just have to put the pieces where they belong. So where does that 5 go? Well, the 5 is up. It must be the power. The power goes up like a flower, so that 5 is out here. And the 3 is below deck, must have been the index. And now we have to calculate. Cube root of 8 is 2, still being raised to the 5th power. 2 to the 5th, you can count on your fingers if you want. 2, 4, 8, 16, 32. And that's our answer. Part H, 1/8 to the negative 5/3. So first thing I'm going to do here is handle that negative sign. I don't like having negative exponents. So I'm going to make it positive, and there are a lot of different ways to do that, but I think the easiest thing to do in this case is remember that if you have a negative exponent on a fraction, that negative exponent acts like a reciprocal maker. It just flips the fraction over. So this is equal to 8 over 1, flipping the fraction over, and that negative sign has done its job. It's not there anymore. So now it's a positive 5/3 power. Okay, 8 divided by 1, silly to write that, we'll just write it as 8 to the 5/3. Seems like we should start going through our process again with the index and the power, but it's no coincidence. This is exactly the same problem that we just did. 8 to the 5/3 is right there. So we're not going to go through the same process because we'll just get the same answer at the end. It's still 32. Part I, 3x in parentheses squared, y to the 5th, z, all divided by parentheses x, y cubed, z, close parentheses squared. Okay, there's only one right answer and probably a lot of ways to get to wrong answers here. So let's see if we can follow a process and get to the end. So first thing we'll do is square this thing right here. 3x is being squared, which really means that the 3 is getting squared and the x is getting squared. So the 3 getting squared gives me a 9. X getting squared is just x squared. And now we've dealt with the parentheses, so I don't need to write them anymore. And we're going to play the same game on the bottom. We're going to square everything, the x and the y cubed and the z. So x getting squared, that's easy. It's just x squared. I'm going to skip past the y for a moment. Z getting squared, also easy. And now we have y cubed getting squared, which I'm just going to write the little work down here. This is y cubed getting squared. And as soon as I write it like that, immediately it jogs my memory and says, oh, what should I do with those powers? We multiply them. So y to the 6th is the thing that goes right in there. Okay, so we're going to look around and cancel. So let's go ahead and start crossing things off. I've got x squared upstairs, x squared downstairs. In terms of the y's, I have y to the 5th upstairs and y to the 6th downstairs. So when I cancel, how many are left over? Well, what do we do with the powers when we divide like this? We subtract those powers. So we have 1 left over because 6 minus 5 is 1. But where is that 1y? It's in the bottom because that's where there were more of them. There are y to the 5th upstairs, but there's more. There's y to the 6th downstairs. So downstairs, we have that 1 solitary y left over. Same idea with the z's. You're going to subtract the powers. There's an invisible 1. So 2 minus 1 is also 1. So we have 1 z left over. And where is it? It's also in the bottom because that's where there were more z's. There were z squared compared to only z to the 1st. So there's a solitary z left downstairs. The x's we've canceled. What should we put upstairs? Well, if there's nothing left upstairs, then it's a 1. You have to put a placeholder. The placeholder is 1 if there's nothing left. But there was something left up there. There was the 9. So that's what goes upstairs. Okay, and then finally part J is negative 3/5 x squared times the quantity 5x cubed minus x squared over 3 plus 4 over x. Okay, let's work our way through this one. So first thing we're going to do here is distribute. That negative 3/5 x squared is going to come in and multiply by every single term. Just have to be really careful when we do it. So negative 3/5 times 5. 5s are going to cancel, and I'll just be left with negative 3. X squared times x cubed. I'm going to say a lot and write very little. X squared times x cubed. What should we do with the powers? We keep the base and we add them. I encourage you to write out all the details unless you're super comfortable with this. If you don't see where that negative x to the 3x to the 5th came from, write it out. Write everything out. Okay, moving on. This is now negative 3/5 multiplied by that guy. And the negatives are going to multiply and cancel each other, so we're actually going to end up with a plus. Okay, and now we're doing the 3/5 times the 1/3, I guess, and the 3's cancel. So we're actually left with just a 5 on the bottom. Again, saying a lot and writing very little. Write out all the details if you don't see it. Right away. Okay, and then all that's left there are some x squareds. X squared multiplied by x squared. Keep the base, add those powers. We get x to the 4th. Upstairs. Okay, and then the last one, we're now going to do this thing times the 4 over x. So when we multiply the numbers, I've got a negative 3 times a 4, that's a negative 12. 5 on the bottom, there's not really anything to match it with, so it's just negative 12 over 5. And then thinking about the x's, there's an x squared here, and there's an x in the bottom. And this x squared, if you have to pick, is it either upstairs or is it downstairs? Well, it's upstairs. It's really over 1 if you want to write it out. So you've got x squared on the top, x on the bottom. One of them cancels, and you're left with a solitary x upstairs. So we're going to put that x next to the 12. So again, with very little writing, but a lot of work that happened kind of behind the scenes, that's our answer. There isn't really much you can do with that. You can try to find an LCD and put it all over 5 if you wish, but I think I'm going to stop with it right there.